Well, I think that we can start this webinar. Hello, everyone. I'm Francesco, Sales Manager for UK and Nordics here at Move Solutions. Happy to see a lot of you connected for this new webinar that is Smart Track and Landslip Monitoring Solution. And I'm super happy to be here with Mark Anderson, Director at Academy Geomatics, one of our trusted UK technical partners alongside Terra Measurement and Encompass Survey. And I will start with a brief introduction, of course, of our company, our system, our solution, and then I will leave the floor to Mark and the project that we are discovering together today. So basically, Move Solution, for the first timers, let's say, we are an Italian company, pretty young company, that now has become one of the trusted leaders in the market for the structural health monitoring system. We designed everything. We designed from the hardware part, so the single sensor to perform static and dynamic structural health monitoring, to the connection, so to take the data from the sensor, to the to connect the data from the sensor, to the platform to visualize and basically understand the data. So we have also designed the full software solution at the end, that is MyMove, the platform that I'm going to show you a little bit later. So just a quick understanding on how is built our system architecture. We have this battery-powered LoRaWAN wireless sensor that communicates with our gateway using, of course, the LoRaWAN signal. So we have this star system where each one of the sensor takes data, measures data, and sends everything to our gateway. Our gateway is the only part of the system that needs to be powered with, for example, connecting to the electrical grid, or, for example, with a solar group, so solar panel and solar battery for like standalone installation. Then from the gateway, with the internet connection or LTE connection with a SIM card that you can put inside the gateway, all the data will be sent to our servers, where our customers can choose if analyze, manage, store all the data on our IoT platform, our brand new IoT platform that is MyMove, or to get all the data and also the algorithms for the structural health monitoring with the API, or just the data with the FTP or MQTT. What are the advantages of this system? The ones that, of course, we will talk about later in depth, looking at Academy's project. The most common, the most important advantages of a smart remote monitoring system are, of course, the reduction of manual and on-site measurement, because you will have to go less times on site to perform inspection, because you will have a system in place running 24/7 and sending you data in remote, of course. At the same time, the second most important is reducing the downtime and the disruption to regular operation. And this is like the case, for example, of this project, because we are going to see how having a system like this in place helps the railway operator to reduce downtimes, closure, and disruption to operation, and, for example, train passaging and train traffic. With a system like this, you will have a real-time and continuous data visualization easily from remote, easily from your office, from your home. And you will have basically the power, the possibility of unlocking the real predictive maintenance of your structure, in order for you to understand how the structure is behaving, how the structure is aging, thanks to the long-term data analysis tools and possibilities that we offer on our IoT platform. A system like the Move Solutions one is is super modular, because it's not good just on railways or bridges or etc., but it's possible to deploy this kind of kit, this kind of sensors basically anywhere. These are 4 of our core expertise. We have tons of projects involving construction site monitoring, because we have, for example, our vibrometer that is great to check the peaks of velocity of the vibration of, for example, a construction site that is undergoing where they are maybe performing drilling and piling works. Speaking about bridge monitoring, maybe we are speaking about the real core business of Move Solution, the first project where we started back in the days, because we have patented and dedicated systems like the Dynamic Displacement Sensor, our sensor that is capable to give you the dynamic displacement directly in millimeter of the point of installation. That is great to check the aging and the health of the span of the bridges. And at the same time, we have a patent on our accelerometer, where you can basically synchronize the reading from our accelerometer in order to get the natural frequencies of the structure and perform the frequency domain decomposition on our platform and perform a full model analysis of the structure. So model analysis of complex structure to have over the long term, like months, years, the status of these natural frequencies of your structure, to understand how the structure is aging and behaving, for example. We have all the part of railway monitoring, where we can, that is of course the focus of the webinar today, because speaking about railways, we have the possibility of performing the full track geometry monitoring, the cant, the twist, the vertical deflection of the track. With the DDS, we have the possibility of inspect the ballast void condition of the railway, and with our tiltmeters, we can check the landslides or maybe the embankment at the side of a crucial and key part of the railway infrastructure. And to conclude, we have the possibility of perform the vertical structure monitoring. We have tons of vertical structure, and for example, we have here in Lucca, the city in Italy where we have the headquarters, we are taking care of the stability and the inclination of a huge historical medieval tower bell of the cathedral of the town in the real city center. So let's bring the focus to the topic of today, of course, so the smart railway monitoring and which kind of application we can propose with our system. We have tons of different applications that we can offer with our system and with our configuration of sensor. And here you can find some great examples. With our tiltmeter, it's possible to check the slopes and the embankments near the railway track. With our tiltmeters mounted on tilt beams, we have tools and algorithms to perform the inspection of the tunnel convergence or the vertical settlement of the railway track. At the same time, still with our tiltmeter, it's possible to check the twist and the cant, and so the main parameters of the track geometry of the selected railway track. Then for example, with the mounting a dynamic displacement sensor in the very center of the sleeper of a railway track, it's possible to understand on the y axis how directly in millimeter how the track went basically up and down, understanding, reading these graphs, reading these single events and this movement, if the track is going more or less, is moving more or less, understanding like this if the ballast is basically compacting or if the ballast is fading away, giving you the possibility to take the right action at the right time. Same thing for maybe other project that doesn't involve the geometry of the railway track. We have the possibility with our single channel node, that is basically our logger, to digitalize and transform into wireless probe, the wired probe that you can find in the market. So, for example, as you can see in this slide, you can connect a crack meter to one single channel node and having the data for the bridge joint monitoring remotely. Or at the same time, you can connect a water pressure and water level sensor to our single channel node, so a piezometer, to check these geotechnical parameters with our system. And to conclude, another application that we already have in place here in Italy is placing our accelerometers to discover the natural frequencies and the modal shapes of a railway viaduct, so a complex railway infrastructure that is, I think, right now some cutting-edge technology, speaking about predictive maintenance and structural health monitoring. So let's switch the focus a little bit on the software part. Our software, as I told you, is called MyMove, and with our IoT platform, our brand new IoT platform, you have the possibility to manage, explore, and analyze all your data from our sensor in the very same platform, in the very same software. What you can do, what's new with MyMove? Inside MyMove, you will unlock the power of multi-project management. So you will have your platform to log in, and inside your platform, you will find a summary page with different projects, like you can see here, with the structure name and, for example, some notification or some insights, like the number of alarms and the color of alarms in the last 7 days. So you will have the most critical information always under control. And inside MyMove, in the analytics page, you have the power to do custom charts as you want. Inside analytics, the analytics page, you can build how many graphs you want, basically overlaying and seeing in the same graph all kind of measure that you prefer, giving them different colors, different names, even with different units of measure. So it's something super helpful to understand better the structural aspects, basically, of the structure. Then we insert the 3-level alarm: yellow, orange, and red, different, of course, in base of the level of warning. So like alert for yellow, warning for orange, and a critical stage for the red. And of course, you will see all the alarms that went off on the project in a alarm list page. So a super good summary of all the alarms occurred in the history of the project. And at the same time, you can set up the email notification to get alerted when an alarm runs off, basically, and maybe when an alarm goes from yellow to orange, orange to critical. And then the super new updates, that is something really new, like 2 weeks, we have the automatic report tool that, doing a little spoiler, will be the topic of our next webinar that I will show you later. So with this tool, you have the possibility to basically build the template, a standard template of a report, an automatic report that you like, that our platform will submit to you, will give you the possibility to download it. You can change, of course, the title, you can insert all the text and images that you need, that you want. And inside you can build your own graph, like in the analytics page, in order for you to have the most important graphs always updated inside the automatic report tool. And this is something that we think will be really, really helpful for a lot of our customers. And with, since we are speaking, of course, of railway track geometry and smart railway monitoring, you will have the full portfolio of algorithms to check the geometry of the railway track. We have algorithms and graphics to see the cant, the twist, the vertical settlement of the railway track. And at the same time, we have basically a page where you can find the railway tools, where you will be able to like create a sort of digital twin of your railway track, having the possibility of dividing the tracks in some like the tunnel track, the Rome to Florence track. So create a real digital and virtual twin to check the cant, twist, and the vertical settlement of the different parts of the track. So now I will leave the floor to Mark, that will explain us what did he do, what Academy did on this super interesting project.
Thank you, Francesco. Yes, so I'm Mark Anderson from Academy Geomatics, one of the directors. We're based in the northeast of England. We're geospatial experts, and more importantly for the remainder of this presentation, monitoring experts. So this is a recent project that we've undertaken this year. It's an active landslip site which is threatening a heritage railway. The client's the National Park and Heritage Railway. This is probably one of the technically most challenging monitoring job that we've been involved with for various reasons, which we'll get into. But more importantly, the reasons for the monitoring was, one, to study the ground movements and see how stable and prove whether or not additional work was to be done, and as an alarm system for the railway itself to protect the passengers and everybody who works with the railway. So this is part of the orthophoto that we've created from the drone surveys that we've undertaken at the landslip sites. We can see here the landslip moving down towards the railway track. We can see here how the fence line is deviated because of the landslip, pushing the material towards the railway track. And we can also see here how the drainage ditch, the upslope drainage ditch, has sealed up because of the material flowing down the hill. And as there's a number of culverts running under the track in this location, the worry is that these culverts might collapse, these culverts might fill up with water, the water might start to seek alternate routes through the railway embankment, essentially, to the stream there. There's a stream at the bottom. So the monitoring was critical to make sure that the railway is going to stay stable. Also in the vicinity of this landslip, again covered by our drone surveys that we've undertaken on site, there's historic landslips. So again, we can see here the thrust is here. You can see the line of the fence there being deviated. You can see the ditch, the drainage ditch being completely closed in. And again, we can see here, but being on site, you can kind of see that there's no further movements there. So they may have played their part and be done. But this one is certainly clearly active. So the monitoring requirements of the project. We were asked in December 2022 to provide a quotation for the monitoring of the landslip, and more importantly, to provide remote video monitoring of the site. One, so we could see how things were moving, and two, so that we could actually dial into the cameras if something did happen and see what's happened, see if the track was clear, check to see if it wasn't just a sheep having a bit scratch against a sensor, things like that. So that's kind of what we went to site looking for. We did a site visit mid-December, and this is the image from it. You can see it's fairly bleak. And straight away, there was a number of problems identified. Straight away, there's no power. Obviously critical for powering the equipment, any monitoring equipment that you need to provide to do the job. There's no phone signal in the valley. Obviously, we need to get this real-time data out to our servers and to Move Solutions servers. No phone signal. There's also no stable ground. Literally, the only stable ground that appears to be in the valley is the railway track and this service vehicle track, which leads to the next problem, the fact that there's no space. We literally have the escarpment coming down the track, the railway track, sorry, the access track, and then the back. There's no room to mount any equipment. The total station wouldn't be of any use for this job because there's nowhere we can put it. A total station doesn't necessarily be put somewhere stable, but there's just nowhere that you can put it that would see the site. So it was fairly clear that we had to go down a tilt sensor route. And we paid another site visit in early January 2023 to find phone signal, source power, things like that, which leads on to our proposal. Sorry, this is a part of our UAV LiDAR survey, which highlights the lack of space in this location. So this is a cross section through the valley. So here's our landslip. This is the railway. This is the gravel access track, and this is the stream. We can't put anything in this access track because vehicles use it all the time. You can't put anything too near the track because there just isn't the room. The stream's a no-go because of the fluctuations of the water level. So sensors that don't require line of sight were definitely favoured for this. So our proposal. So this is a summary picture. So for the landslip, we proposed 24 tilt sensors in an 8x3 array. We additionally wanted to put 4 tilt sensors on the track, so we knew what was happening. So we'd know the differential between what was happening on the landslip and what was happening with the track. We also wanted to put 4 accelerometers on the track, so we could get the dynamic information from the track and potentially the modal analysis of the track. And also we wanted to put 1 dynamic displacement sensor in the middle of the track, so we'd see what the instantaneous vertical movements of the track would be and see whether or not that was going to degrade over time, see if there were any ballast voids were developing because of the culverts being closed up. That was the proposal was fairly straightforward. The problem was power and comms, as ever. So how did we facilitate this? Well, we needed a remote power station in the middle of nowhere. This remote power station has 2 400-watt solar panels, which are pretty big. We've got a 1.8 meter diameter wind turbine on the top. We've got 5 250 amp hour batteries, which are 66 kilograms each, which is a fair old weight to be bumping up the escarpment to place in the bottom of the tower. A 10 meter tall custom tower. So that gives you an idea of just how big these solar panels are. And all the electrical equipment is mounted within the base. The Move gateway is on top for a better view of the sensors 300 meters down track. It's truly a terrible location for solar. In the winter, we get about 2 to 3 hours of direct sunlight at the site, so that's just not enough power. But luckily, this setup is doing really, really well. Like I said, it's 300 meters along the track from the landslip. As for the comms, we did consider Starlink, given the remote nature of the job, but Starlink's just too power hungry. For the power budget that you would require, essentially we would require 2 of these setups, which just was outside of what we really needed to do. But luckily, on the second site visit, we found plenty of phone signal up the escarpment, so we were able to extend the existing solution up to the escarpment and get the data out to the outside world. Got a few images of the monitoring installation being installed. So the tower base was dug and poured in December 2023. The tower was installed at the end of January 2024, so this year, and then the monitoring equipment was installed at the start of February 2024. So we've got about 5 months worth of data there already. For the tilt array, we've got 1.5 meter poles driven in at 1 meter with 0.5 meter left proud of the ground. The tilt sensors are mounted on the top. We've also surveyed it in accurately all the sensor positions. So every time we do a servicing visit, we can remeasure them to give a real world dimensions. So we can see how the change in tilts relates to real world distances, just to give the client some reassurances. We're also monitoring the voltage of the remote power station using a Move Solutions single channel node. We're also monitoring the stream level, which is over here, where we've got sensors on that, giving us the real-time levels of that. And we're also measuring the rainfall levels as well, so we can see if there's correlation between all these different variables and the movement of this landslip. If we have a quick look at the monitoring results, the DDS, the Dynamic Displacement Sensor, was immediately the most interesting of the sensor results. We could identify the number of axles on every train that was passing. Using the remote video footage, we could obtain the length of the train and calculate the speed of the train, given that we know how long it takes it to pass over the sensor. Any responses and any changes in response could be an issue with the track, potential ballast void, things like that. And eventually, once the system learns, potentially we'll get the modal frequency statistics out as well. With the accelerometer results, what's been interesting is that the correlation between the DDS and the number of axles is evident in the accelerometer results. Any change in the accelerometer responses in various directions, again, could indicate a ballast void or problem with the track drainage and things like that, or the culverts underneath. And again, over time, we will achieve the modal frequency statistics. But interestingly is the difference in the acceleration results across these 4 sensors with the same train. It varies massively between, over a span of about 40 meters, 45 meters. In this results here, we can see here, this magenta line is a peak here, and we've got a peak here. On these peaks, that was actually a diesel train, and the rest of the responses was a steam train. So clearly a change at that location in the track due to the load that was put on it. The tilt results are very interesting. There's only a small correlation between the tilt movements and the temperature, possibly because of the poor environment that we're putting this kit in. Doesn't see a huge amount of solar activity, which isn't great when you put the remote power station in. The center top of the landslip at present is more active, which is great because that means we've targeted the right area. As things progress, perhaps more of the other tilt sensors will start to show movements. There's a strong correlation between the rainfall and the water level. In this example down here, this blue line here is the stream level, and this blue line here is the rainfall level. And we can see here this very center top tilt sensor has sort of shot off on its own and has not come back, coinciding with the 2 peaks. And this was a very wet period at the start of February, actually. The sensors on the track are really interesting as well. You can see the spike nature of them, giving us assurance that the track is returning to its sort of rest state once the trains have stopped for the day. But again, if any of those exceed standard tolerances, we'll know about it and then we can investigate further. So that is this project. I'll hand it back to Francesco. And if anybody has any questions, we can answer as best we can.
Absolutely. Thank you very much, Mark. It was really, really interesting also to see the final graph of the DDS, the accelerometer, and the tiltmeter to really understand what's happening on this side. So I will just show you our next webinar that I think that now you are seeing. And if you want to ask us some question, you can find the question and answer box here on the Zoom webinar. And in the meantime, I will announce our new webinar in basically I think of July, where Matteo Lencioni, our product manager, will do a live demo of all the new features of MyMove. So will be like a live stream of the analytics, a live stream of the report, the automatic report tool, and what's new in MyMove, and what MyMove has to basically offer you. Now, if you have, we'll wait a sec for some questions. We have Mark. I think this is a question for you from Mohammad. How deep the rods being installed on the slope with tiltmeter on top?
So the total length of the rods that we've used are 1.5 meters long, with 1 meter being installed in the ground and 0.5 meter proud of the ground. I imagine most sites will vary given its topography and underlying sort of soil strata, but certainly for this, 1.5 meters seem to be spot on.
And we have another question from Amit. Is MyMove free when the user purchases the product? MyMove has a current fee that is basically an annual fee of the software platform that is we can quote you depending on the number of sensors in the project and depending on which kind of tools you need to use on your project. So thank you very much. I think that you can find me on my email, francesco.valenti@movesolution.it. You can write an email to info@movesolutions.it if you have questions for me. If you have questions for Mark on the project, or further project, I will be happy to put you in touch with Mark and with all our technical partners in UK for possible project and collaboration. Of course, this webinar is recorded, and you can find, we will send you the link of the recording later in these days, and you can find the record on our website. Thank you very much for staying with us, and have a good day. See you soon.
Bye now.